Today we're jumping into a really cool case study. It's all about how artificial intelligence is helping solve one of the most basic, but also one of the most critical challenges a country has, literally keeping the lights on.
I mean, think about it. It's a question most of us never really consider until, the power suddenly goes out. But for the people in charge, it is a massive, non-stop puzzle of supply, demand, and a ton of moving parts.
And for the island nation of Sri Lanka, this puzzle has gotten especially tricky. As its economy grows and society modernizes, its appetite for electricity has just gone through the roof.
So let's dive into this puzzle. Because to really get why AI became so essential, you first have to understand the sheer scale of the challenge Sri Lanka was up against. Okay, check this out. After the civil war ended back in 2009, Sri Lanka's development just exploded. For 15 years, electricity demand shot up by an average of 4.4% every single year. And then you get to 2016. Peak demand leaped almost 9% in just 1 year. And it's not slowing down. This isn't some gentle slope, it's a steep, relentless climb.
So how is the national utility, the Ceylon Electricity Board, trying to keep up? Well, they were using a pretty traditional method. Engineers would look at old data and then kind of use their best professional guess. But with growth this explosive, that gut-feeling approach just wasn't going to cut it anymore. They needed something way smarter, faster, and totally driven by the data.
And the stakes here? They couldn't be higher. This line from the research paper says it all. If you get your forecast wrong, it's not just about a few lights flickering. It means you're either wasting a ton of money by producing too much power, or even worse, you're choking off economic growth because you don't have enough. Getting it right is absolutely critical. So a team of researchers started hunting for a missing piece of this puzzle, some hidden variable that could make their forecasts way more accurate. And it turns out they found it by looking up at the sky. And this is where the story gets really interesting. Sri Lanka is a tropical island, right? So its weather is dramatic. We're talking scorching heat, 2 different monsoon seasons, the whole deal. And this doesn't just affect how much power people use, cranking up the AC. It also affects the supply, since a huge chunk of their energy comes from hydropower. Weather isn't just some minor detail here, it's right at the heart of the whole energy equation.
So that led to the million-dollar question. You've got temperature, you've got rainfall, you've got humidity. Which one is the real driver of electricity demand? They all sound like they could be it, but if you're going to build a smart AI, you have to know which signal truly matters the most.
To figure that out, they brought in a pretty powerful statistical tool. It's called the Granger causality test. The easiest way to think of it is as a kind of causality detector. It helps you see if one set of data, like temperature, is actually useful for predicting another set of data, like electricity demand. It's about finding real predictive power.
And the results were fascinating. The test spits out something called a p-value. Now, all you need to know is that a really low p-value, less than 0.05, means you found a strong causal link. And would you look at that? Temperature has a super low p-value. That's a strong connection. Humidity shows a little something in a few places. But rainfall, get this, the data showed no meaningful causal link to electricity use at all. Surprising, right? So there it was. They found their smoking gun. It's temperature. And it makes perfect sense, right? When the days get hotter, people everywhere turn on their fans and air conditioners, and boom, energy demand spikes. Now they had the magic ingredient for a truly powerful AI model. But just knowing that temperature was the key, well, that was only half the battle. Now the researchers had to find the absolute best AI tool for the job. So they decided to set up a little competition, a head-to-head AI versus AI showdown. So in one corner, you've got Team VAR. Think of this as the seasoned statistician. It's really good at seeing how different things, like temperature and past electricity use, influence each other right now. And in the other corner, you have Team LSTM, a type of neural network. This one is more like a deep-thinking historian, built to recognize and remember complex patterns over really long stretches of time. So the training camp for this competition was intense. First, they gathered 7 years of data. They cleaned it all up, getting rid of any errors. Then they fed 80% of that data to both models, basically letting them study and learn the patterns. Finally, they kept the last 20% of the data as a surprise final exam to see which AI could more accurately predict what was coming next. And that brings us to the final round, the results of this AI face-off, and what it all means for Sri Lanka's future. So after all that training, all that testing, which model actually came out on top? Was it the statistician or was it the historian? Well, The numbers speak for themselves. This scorecard here is from one of the districts, and it tells a crystal clear story. For these kinds of tests, a lower score is better. It means you're more accurate. And look at this, the VAR model absolutely crushed it. Just look at that mean square error, 5.7 for VAR versus almost 40 for LSTM. Wow, it wasn't even a close fight.
But let's zoom in on what might be the single most important number on that entire chart, 2.15%. That was the VAR model's mean absolute percentage error, or MEPA.
So what on earth does that mean? It's simple, really. It means that on average, the VAR model's predictions were only off by 2.15% from what actually happened in the real world. For a system as complicated as a country's power grid, that is an incredible, almost unbelievable level of accuracy.
So the verdict was in, and it was unanimous. By smartly weaving in that key weather data, temperature, the VAR model proved to be a powerful, reliable, and super accurate tool for predicting Sri Lanka's energy needs.
And this whole story leaves us with a really fascinating final thought. Sri Lanka's success here shows the amazing power you can unlock when you combine local, real-world data, like the weather, with the right kind of AI. It really makes you wonder, doesn't it? How many other huge, complex problems around the world could we solve just by looking for the hidden patterns that are hiding in plain sight?